Hello and welcome to this short introduction into SQL databases. Databases are good at storing data, retrieving data, sorting data, and can be used by many people at the same time. Databases are made for dealing with persistent data. There are many kinds of databases. We are focusing here on the Microsoft SQL Server, but we also have Oracle, IBM, MySQL, and many others. And I haven't mentioned all the non-SQL databases. A database is typically installed on a server, and we are accessing this SQL server through, for example, C#. We are accessing actually the DBMS, the database management system. The DBMS, the database management system, is then accessing the database for us. At this example, we have some kind of a program that can inquire and get responses from the DBMS. We have some new data we are entering through at Edit software, and we can generate reports. The DBMS that we'll be using looks like this. This is the Microsoft SQL Server Management Studio. And here we can see that I'm connecting to a server called ERL00134. Usually when we're dealing with objects in C#, they'll look like this. We have this student class that has the name, class, city and street. In the main, we have a reference to an object of the type student. In the database, it will look like this. Then we'll have name, class, city and street, just like in the object. But here we have a reference. Instead of a reference, we have an ID, a unique identifier. In this, it is 4 for Paul, 5 for John, and so on. So there are differences between our C# program and our SQL database. For example, C# has a reference to each object, while in a database we have tables with unique identifiers to each row. In C# we have properties, in the database table we have columns, and in C# we have types like a string. In databases they will be called n-varchar, and in this case it's 50, which is telling me that there can be a maximum of 50 characters in this. And in C# there are many more variable types, just like in SQL. Let's start this demo by connecting to our database server. We can see that we have a lot of folders. We have database, we have some security and other stuff. The only part we'll be looking into in this video is a database. And I have two databases that are default here, and one I have made by myself. For this demo, we'll be creating a database. You might be handed a database and therefore you don't need to create one. The creation of a database can be both simple and advanced. We are taking the very simple part here. We're just going to say create database called DemoDB, and it will be created with the default values. Command was a success. We can update the database here and see that we have created our database, but we don't have any tables in it yet. Also, a database contains lots of folders, and for this demo we'll be looking into tables only. Here are the SQL command for creating our table with a unique identifier, that is starting with 1 and increasing by 1 for each record. We have a name, which is a varchar, and n-varchar is a bit like the string, unless that this can be of a maximum of 50 characters. We have the n-varchar 10, which is a 10 character string. We have city of 40 characters and a street of 40 characters. We can also see that these 3 columns cannot be null. There have to be some kind of information in the identifier, in the name and in the class, but street and city can be null. We can also see here that we have identified the ID column, which is this one, as to be a primary key. Let's try and make the table. And if we are refreshing, you can see that we have the table here. We can ask the database for the table's content. It looks like this. We haven't filled in any data yet. When we want to insert some data, we can do it like this. Insert into students. Students are our table name. We have name and class, which is the columns we want to add in Mutugluk, and DMO 1, 2, 3i, which is a fictionary name and a class. Let's insert the data. Now we can try and select the data once again, and we can see that we have one name in a class, we have null as a city and null as a street, and the unique identifier is 1. We can also insert a student called Mutugluk 1 and Mutugluk 2, which lives in Odense and in Thomas Street in the later, like this. Once again, we can select the table, and we can see that it now has 3 persons in it. We can also update a person within this database. So we'll say update in student, the table, set name equal to Gugu, where the ID is 2. So we are changing this name and this name only. Where the ID is equal to 2, we are changing the name. And we can see that the name is changed. That was an update. When we are selecting students, we can select by many different approaches. For example, we can just select all using the select ID, name, class, city and street from students. But we can also select ID, name, class, city and street from students where ID is smaller than 3. ID smaller than 3 would be ID equals 1 or 2. Let's try that. Getting only ID 1 and 2. Or we could say equal to 3. Getting only this one. Or we could say where name equals Mutugluk. We can also say delete from students where ID equals 3, so we want to delete this row. And we can see that we only have 2. But be careful with the delete. If you don't use a where clause, you'll have the delete from students. I'll give you a few seconds to guess what it will do. I hope you have a good guess. 2 rows affected. What's in the table at this moment? 0 rows. So we have deleted everything. So be careful with that. The last thing I'm going to show you is that we can add some logic. So instead of this select and insert, we can make a procedure to do this for us. So here I have the script creating a stored procedure called select student. And it takes an ID and it just selects, as we have said before, every ID, name, class, city and street from students where ID is smaller than whatever we handed it to it. So let's insert some new data. And we can see down that we have 6 rows. And the ID is now starting by 4 because we had 1, 2 and 3 but deleted them. So the identity will keep on going. We wouldn't have the same name twice even though we have deleted them. And satisfied with the data, we'll make this stored procedure. We'll execute it, saying the procedure is stored, which is create the procedure, so the procedure is created, and then we can use this procedure here where we want to select 1. Remember that the procedure would select students with an ID lower than the number we are giving it, and lower than 1 would be 0, and that doesn't exist, so it will return 0 rows. We can also say 4 as we know that row 1, 2 and 3 are deleted. Still giving us 0. We could say 6 knowing that there are a 4th and a 5th row. Yes, we were in luck. And we could say 600 knowing that we won't have 600 students and we will get it all here. Like this. That was what I was going to show you about SQL servers for today. Have fun out there.